What's up, guys? I think I just love filming these on my days off. I don't know, just something about it, you know? In any case, let's get straight to the nucleus of this dilemma here, the dilemma that is chapter 9. A lot of ground to cover. Let's get started. So 9.1 dealt with Pythagorean Theorem. You guys learned about this in 8th grade, but it's making a re-entry. I'm going to mark the hypotenuse. You should know by now that the hypotenuse is across the 90-degree angle. A squared plus b squared equals c squared. Again, c is the only one where the placement of it matters. Everything else, you can either call this a or b. You can call this either a or b. Just choose one, stick with it. So that's just going to become 8.3 squared. This one, let's just substitute in x. And then c is going to be 12.3 squared, right? This guy is the one that has to be in that proper position. Again, these all just drop down, right? 8.3 squared is like saying 8.3 times 8.3. That's just 68.89. 12.3 squared is going to be 151.29. These are done on a calculator unless you're a genius wizard. Not me. Now, this is going to just give us the following equation. If you want this guy by itself, we need to move that guy over. So the way we're going to do that is, subtract 68.89. Okay, that's going to allow us to cancel. This is going to give us x squared equals whatever this turns out to be on a calculator. I believe that is going to be 82.4. And then think about it. How do you get rid of this square? Well, the thing that you need to know about the square is that it's the inverse operation of the square root. So these two cancel, leaving you with just this guy in the middle. Okay, that's just going to be x. Once you calculate, oh, that's not what I wanted. Once you calculate square root of 82.4 in your calculator, I believe you should get something around 9.077 ... Okay, I should have drawn a little squiggly. Do note that. That's going to be approximately 9.1. Okay. Okay, so there's our answer. Again, what did we find? We found that this right here is actually 9.1 yards, okay? It's great if you put the units, but if you don't, at least get the numerical answer. Let's do the next one. This one's different in the sense that the hypotenuse is now a variable, okay? So you're going to have to solve it a little differently. A squared plus b squared equals c squared. Again, not exactly differently, but let's just call these a and b. That's going to be 4.4 squared plus 10.5 squared equals x squared in this case. C is just x. I'm going to zoom in. Now that's going to give us 4.4 squared is going to be 19.36. 10.5 squared is 110.25. And the x squared just stay the same. You can combine those two. That's just going to become 129.61 equal to x squared. Again, you can skip a step here if you already know what to do, but you really should be square rooting both sides, right? Square root, square root. What will happen is these guys get knocked out. So you're going to end up with just square root of 129.61, which on your calculator should be 11.3. Ooh, not that bold. I'm not that bold of a person. There you go. Again with the squiggly. There you go. So that's going to give you 11.4 approximately. Again, just round up if the question asks you to. In this case, I believe the directions did. This is 11.4 centimeters. But again, I don't know. I haven't put the units. Let's keep going. It doesn't matter if the triangle is inverted. I'm just going to quickly highlight the hypotenuse, which you know is across the 90-degree angle. The other two, the order really does not matter. Okay, you could call either one of those a and b. So a squared plus b squared equals c squared. That's going to give you, let's just plug and chug, 9.5 squared. That's going to be just x squared, right? This guy is x squared. And then the hypotenuse is the only one that matters, 14 squared. Again, these two, 9.5 squared is going to be 90. Ooh, that's ugly. 90.25. X squared just drops down. 14 squared is going to be 196. If you subtract, don't forget the decimal, you're going to end up with x squared equals 105.75. And then in that case, you're just going to square root both sides, right? So cancel. This should give you with x, not again, x is approximately equal to the square root of 105.75. That's 10.283, which is approximately 10.3. Again, calculator usage. I'm not a genius. I know you think I am, but I can't do that in my head. Okay. Number 4, let's go. This guy right here. Oh man, these are getting sloppy. So again, it doesn't matter which one you call A and B. The C is the only value that matters. So A squared plus B squared, and again, C is across the hypotenuse. This is going to give us 7.9 squared plus 9.7 squared equals x squared. These two, they just combine. Well, okay, we'll do it one at a time. Again, 7.9 squared is 62.41 plus, this is going to be 94.09. X squared just drops down. I don't know why I changed it from an arrow to changing it to brackets. Whatever. This is going to become 156.5. X squared drops down. Again, last step. Square root. We know that these two should cancel. In which, oh man, these are getting real sloppy. This is going to be 12.509 is approximately equal to x. That's 12.5 approximately equal to x. That is going to be your answer. This guy right here. Okay, that's 12.5. Okay, let's move on. Still in the same section, 9.1, but this is a matter of, is it acute, obtuse, or right? Okay. Personally for me, I mean, the right triangle is pretty obvious for me. It's just the Pythagorean Theorem. Now, between people, I think they get confused with obtuse versus acute. Well, here's the thing. I think about it intuitively. If something is less than, I mean, in this case, c squared is a hypotenuse, right? If they're saying the hypotenuse is the bigger one, right, compared to a squared and b squared, the other two sides, well, then you can imagine the hypotenuse is going to be fairly large, right? And if the hypotenuse is fairly large, you're going to have an obtuse angle. Okay? So this is the case when c squared is the bigger one. So just a bit of intuition there. Let's get started. For these problems, you really want to treat the longest side as if it is the hypotenuse, even though it actually isn't. So for number 5, this is the longest side. Let's call that C. Okay, we don't know if it's the hypotenuse. If it is, this becomes a right angle. But we're going to have to, double check and see. As before, we don't know what symbol goes in between here. We're going to leave that blank until the very end. Again, let's call either one of these A or B. Doesn't matter. That's 4.5 squared plus 6 squared, and then 7.5 squared. Okay, well, each one of these convert into a nice little number. That's going to be 20.25. That's going to be 36. 7.5 squared is 56.25. Okay. Well, if you add up the left side, that just becomes 56.25. We know that this one also is 56.25. So what symbol goes in between? Well, those are equal to each other, okay? In fact, all the way up to the end. So equal. Well, think about it. If it's the case that a squared plus b squared equals c squared, right? Check your little code up here. Equals is going to be just a right triangle. So this is all that we needed to find. They're equal to each other, therefore it is a right triangle. Number 6. Again, C is the longest side. Let's just call it that. We don't know if it's hypotenuse, but treat it like it is. If we call 12.3 A and then B is 8.4, Pythagorean Theorem. Oh, ugly. Oops. And again, I'm just not going to fill out the symbol for now. Let's call a squared 12.3 squared. B squared is 8.4 squared. And then 14 squared is going to be c squared. Each one of these converts to a smaller number when squared in the calculator. That's 151.29, 70.56, and then 196 is going to be 14 times 14. If you add up the left side, you're going to end up with 221.85. And then on the other side, it's just going to stay 196. In which case, the symbol that goes in between here, okay, it's going to be greater than, right? So think about it this way. In this case, c squared, right, is going to be less than the other two angles squared added up. That is a dead giveaway for an acute triangle. Okay, so let's write that in. This is just an acute triangle, like me, minus the triangle. Okay, let's do this. I hope you're laughing on the other end of this. So again, this is going to be C. And then everything else, again, just call it A or B. Doesn't matter. In this case, I'm just going to call this A. I'm going to call this B. A squared plus B squared, C squared. That's going to give us 7.2 squared plus 5.4 squared, and then 10 squared. What do each of these give us? 10 squared is 100. That one's pretty easy. This one's going to give us 51.84 plus 29.16. Well, these two add up to be just 81. This one just stays 100. What do you know? Here's our third case. This time c squared. C squared is the one that's actually ending up bigger. And remember, this one is telling us that the hypotenuse is going to be a little bit bigger. It's going to be a little bit bigger than the other two sides squared combined. So intuitively, this tells us that this should give you an obtuse angle. Oh my goodness, this is horrendous. I do apologize. I am going a little faster because you can pause, rewind the video. Let's move on. 9.2, find the missing side lengths. These are going to be our 45-45 triangle and our 30-60-90 triangles, if you recall these two. Okay. Again, these triangles have this pattern of either having 1, 1, 1, or 2, 2, 2, 3, 3, 3, and again, any number just gets, the hypotenuse is basically the sides of the legs times square root of 2. We'll touch back on this in just a second. So if you look at this one, well, if this angle is 45, then this one must also be 45. Okay, so let's fill that in. The reason this is important is because that means if the angles are congruent, well, then so are these corresponding sides. So if this is 4, then this must also be 4. And if these two legs are 4, then this must also be 4 times the magic number for 45, 45, 90, which is square root of 2. Okay. Again, this is the magic number for 45, 45, 90. So in short, we know that y is going to be equal to that. And then this is going to be equal to the same thing, just times square root of 2. And again, the way that you get this is because hypotenuse is going to be the leg times the square root of 2, in which case the leg was just 4, so times square root of 2, well, you get the picture. Okay. Look at that symmetry if you don't see it. That's 4, 4, 4 square root of 2, right? It could have been 5, 5, 5 square root of 2. That's basically the gist of 45, 45, 90 triangles. Like if we do this one, this time they gave us the hypotenuse, right? They gave us the hypotenuse, which is 3 square root of 2. Remember, the hypotenuse, well, let's put it this way. The leg is going to be basically the hypotenuse divided by square root of 2. This is the math formula for it. And so if you take this guy, this is your hypotenuse, right? Plop him up here. Well, that's just going to give you, let's keep the boldness. That's going to give you 3 square root of 2 divided by square root of 2. And then these two are going to cancel, leaving you with just 3. And it's really just an over the top way of just showing you that this is how you mathematically get the answer. You get 3 and then 3. But what do you know? Here's the pattern once again, right? You have 3, 3, 3 times square root of 2, right? Just like that same pattern for 45, 45, 90. Again, this is 45 degrees, and we know that because these 3 angles need to add up to 180, and 45 is the only one that does that for us. Okay, let's do 10. Okay, now we're back at 30, 60, 90 triangle territory. So a little bit trickier. I know some of you actually found it easier for some reason, but I don't know. I don't know why. I find these a little bit more difficult. The long side, remember this, just to review. The long side is going to be the side across from the bigger angle. Usually you could tell visually that it's longer too. And then the short side is going to be the one that's across the smaller angle, which again, visually you can tell as well. And it's always going to be in this pattern. The short side is just x, the hypotenuse is 2x, the long side is x squared root of 3, and x can be any number. So for example, let's just jump into it. I feel like that would be the most helpful. Think about it this way. If this angle is 60, that means that this must be 30, right? Because 30 plus 60 plus 90 gives you 180. Okay, let's identify which the sides are. This is going to be this bigger angle, and so this points to the long side. You could tell visually that it's longer too. 30 degrees is a smaller number, so this is going to be pointing to the short side. And again, visually you can tell that as well. The hypotenuse is always the longest, of course, but we don't mind that for now. So, couple things. Might as well label the hypotenuse. We're given the hypotenuse. We're given 14. Something we need to know is that the short side, okay? Something we need to know is that the short side is going to be the hypotenuse cut in half, right? If you divide the hypotenuse by 2, well, you're going to get the short side. So in this case, let's just take our hypotenuse, which is 14, cut it in half. 14 divided by 2, that's 7. Well, turns out that guy just goes where y is. Okay. This is going to be our short side. Okay, we got it because of that. Now we just need to find our long side. Well, our long side, remember, is really the same thing as our short side, but just a little bit longer. Just a little bit longer because it multiplies by square root of 3. This is kind of the magic number for 30, 60, 90. So that's going to give us, again, short side was what again? Well, we said it was 7. Plug it back in. That's going to give you 7 times the square root of 3. Well, turns out you can't really squish those numbers together. Those are not like terms. So 7 square root of 3 is going to be your answer. I'm just going to take this little highlighter. Woo, there you go. Okay. You should see the pattern. 14 is the hypotenuse. Cut that in half. You get 7. And then multiply that same number by square root of 3. You should get the long side. Okay. We'll do number 11. One more. This is 30 degrees, which means this automatically is 60. So 60 points to the long side. 30 points to the short side. And then the hypotenuse is going to be whatever is across the 90 degrees. So if you're given the long side to begin with, okay, if you have the long side to begin with, remember, the long side is really the short side times square root of 3. But we can mess around with this formula, okay? We can mess around with this formula. So let's duplicate this. if you want to find the short side by itself, right? If you want to find the short side by itself, well, how do we do that? Well, we can just divide this formula by square root of 3 on both sides to isolate for short, okay? So, in other words, this guy, let's divide him to the other side. And there you go. Now you have a formula to find your short side, okay? So, in other words, long side is going to be, it's already given to us, right? Long side is 4 square root of 3. Well, if we divide that by square root of 3, again, these are going to cancel. You're just going to be left with 4. This is going to be the short side. And so let's just draw that guy in. Okay, our short side is going to be 4. Okay, and honestly, you could have eyeballed this one, right? You know that this is 4 square root of 3. Well, the short side is literally just that same number, but without the square root of 3, right? But this is the steps to show it. And then think about how you are to arrive at hypotenuse, right? To get to hypotenuse, we know that hypotenuse is going to be 2 times the short side. And so that's going to be just 2 times the short side. Well, what's the short side? Well, we said it was 4 earlier, right? We wrote that down. So when you double that, you just get 8. So hypotenuse is just 8. Again, you should notice this pattern: 4 square root of 3, right? Well, the other one's just going to be 4 without the square root of 3. And then when you double that, you get 8, okay? So different ways to kind of approach this problem. If we look at these next two, they're super easy, okay? Just plug it into a calculator. I'm going to just, off the top of my memory, I'm going to draw a calculator. Beep, boop, beep, boop, beep. I literally did not plan this, but you just plug in tangent of 70. Oh, horrible calculator. You get the point. You just plug it into a calculator. You're going to get 2.9042. And interestingly enough, this one says rounded to the 10,000th, okay? I mean, this keeps going, I believe. But yeah, you don't have to do anything here. Just go ahead and put that, okay? No rounding necessary. Like literally, this is just plug and chug. You're just plugging into a calculator. They're testing you on, can you plug it into a calculator? As long as your calculator is in degree mode, as we talked about in class, you should be good. If for some reason yours says R on the top, let me know. Plug this into a calculator. The next one, that's going to be 0.951056 ... which honestly is just, if you round it to the nearest 10,000th, that's going to give you only 4 digits. That's 951. But because this is a 5, you're going to round it up to a 1. Right. Because this guy is, yeah, we're rounding it. You guys know how to round. 2 freebie questions. Please don't get those wrong. Okay, numbers 14, what am I saying? 14 to 16. These are going to be our good old trig ratios. I need to remind you guys, SOHCAHTOA, don't know why people still don't understand what this is. This is not a hard thing. This is actually meant to help you guys, okay? This is meant to tell you guys, okay, what is sine? Oh, well, according to SOH, SOH, that's opposite over hypotenuse, right? That's sine. This is CAH. So that's cosine A over H. CAH, that's adjacent over hypotenuse, right? This is TOA. That's going to give you T is equal to O over A. That's tangent, which means opposite over adjacent. SOHCAHTOA. I fear maybe I should have explained this more, but again, this is an acronym. You never have to like memorize it because this acronym tells it to you, okay? So again, think of SOHCAHTOA, okay? SOHCAHTOA. Well, according to, I guess I'll just write it up here. SOHCAHTOA. Think about it. Cosine refers to C, so that's going to be AH, right? A over H. So A over H, that's adjacent over hypotenuse. So label your angle Z. That's going to be your theta symbol. Remember the 0 with the half, the slash. Now, according to this, and you got to be careful here, this points to the opposite side, right? Now, this points to the hypotenuse. Now, the one that's closest to this angle, right? Closest to this angle is this side. So that's adjacent. Well, process of elimination, right? Now, the only two that we need is 18 and 30. We actually don't need this guy. Goodbye. Woo. Reason we don't need him is because we just need adjacent over hypotenuse, because it's asking us for cosine. So that's going to be 18 over 30, which if you do the math there, that simplifies to 3.5, or in decimal form 0.6. Either one works if you see it on a test. They'll only give you one or the other. But if you're not sure how you got that, think about it. You're dividing top and bottom by a common factor of 6 is the biggest one, and then that'll give you 3 over 5. Right? This gives you 3, and then this gives you 5. Let's do tangent of C for number 15. Again, label your angle first. Now, again, SOHCAHTOA. Think about it. SOHCAHTOA. I'm not just a crazy person trying to tell you to memorize some random magical incantation. Like, this should help you. So tangent is T, right? And it tells you OA. So OA, that's opposite over adjacent, okay? So you never have to really know it. Oops, this is going to be adjacent. So let's find those sides, okay? Let's find this guy and find this guy. So according to this angle, what points across is going to be the opposite side. What points from the 90 degrees is the hypotenuse, and then the remaining one is adjacent. Well, the only two that we need is opposite and adjacent. We have no need of the hypotenuse this time. Goodbye. Woo! Yeah, they're all going on vacation together to some magic land. Who knows? This is going to give us, and again, be very careful. It's this guy on top, right? Because that's opposite. And then this guy on bottom, because that's adjacent. Don't mix the two up. 40 over 30, if you notice, is just 4 over 3. Think about it this way. These zeros cancel. Why do they cancel? Well, they divide by 2, right? 10. Okay. And again, they might give you the decimal. The decimal is like something like 1.3 dot dot dot. Like it'll give you a little thing on the top here. Goodbye. They're all on vacation. Number 16, sine. Again, sine. Think of SOHCAHTOA. Right? Well, again, if this is sine, well, this is sine. Well, OH. That's OH. Right? SOH. That's opposite over hypotenuse. Okay? This acronym should help you out. So this is opposite over hypotenuse. Draw your angle X, right? Because that's the one they gave us. This is opposite. This is hypotenuse. The remaining one is adjacent because it's the closest one to the angle. Which two do we need? We need opposite over hypotenuse. So that's just 20 over 29, which I believe, as luck would have it, does not simplify. It's actually good for us in this way because that's just our answer. In decimal form, it's something like this. Okay. Okay, so find the missing side, round to the nearest tenth. So this is 9.4 ABC. This is where we're actually using it to find the missing side. And the reason we can't use Pythagorean theorem is because we need two sides given to us for Pythagorean theorem. We are not given that. We're given an angle and we're given a side. So let's work on this together. Again, this guy is your opposite side. And then this guy is your hypotenuse. It's across from the 90-degree angle. Think of which of your trig ratios, sine, cosine, or tangent, uses opposite and hypotenuse. I'm going to tell you right now, it's going to be sine. Okay? Just think about it this way. So, right? SOHCAHTOA. So SOH. So that's going to give you opposite over hypotenuse. And then all we need to do is add the little angle here, 37 degrees, okay? So again, SOHCAHTOA, sine is opposite over hypotenuse. Well, keep writing it in. That's going to give us sine of 37 degrees is going to be equal to opposite over hypotenuse. And again, x is on the top of the fraction. Remember, this guy, you want him to go over to this side, right? You want to multiply him to the other side. So let's cross multiply. Okay, it's as if this guy is going bye-bye. Ooh, and then it just becomes here, and this little fraction bar we don't like goes away. We'll just play it from the top. That's going to give us 20 times sine 37 is equal to x. And again, plug that into your calculator. We know that that's going to give you 12.036 dot dot dot. And that's going to be about 12.0, or you could just write 12, but that's going to be your answer. So yeah, it's approximately 12, interestingly enough. And then if you wanted to, again, you could use the Pythagorean theorem to find this missing side, at least an estimate of it. 18. So let's take a look. So here's our angle theta. That's going to be 72. I'm just going to, maybe this will help to label all of them. So this is your opposite side, right? It's across from the angle, right? It's across from the angle. So, you know, that's your opposite side. We know that this guy up here is your hypotenuse. And then what's remaining? Well, we have our angle. The one closest to the angle is going to be your adjacent side, right? So that's your adjacent side. And again, this guy's not provided here, okay? I just wrote that here just for the purpose of demonstrating. He's going on vacation with the other guys. So adjacent over hypotenuse, which one is that one? Think of SOHCAHTOA, right? SOHCAHTOA. Think about it. C-A-H, right? That's just cosine adjacent hypotenuse, okay? So that's how you know which trig ratio to use. You have, for example, cosine of 72 degrees. We're trying to find the missing side length. Let's do it. Cosine of 72 degrees is going to be equal to adjacent over hypotenuse. That's 15 over x this time. The order does matter. Think about it. Now this time, this x is on the bottom, okay? Now, again, you could do this whole thing where you multiply this to the other side, so you get x cosine of 72 is equal to 15, and then you could divide both sides by 72, and then these cancel. You get x equals 15 over cosine 72. That's a lot of work, okay? I'm not even sure if I've shown this in class. Well, again, this right here and this right here, think about it. It's really just these two switching places, right? So again, I might have muddied the water here. Let me quickly show you what I mean. Again, I described it in class as just switching places, but that's really like you're multiplying. It's really like you're multiplying this to the other side and dividing this to the other side. That's really what's happening. But let's just, for the sake of argument, for simplicity's sake, just call it switcheroo. Cosine of 72 is equal to 15. Again, notice these two switch places, right? These two switch places, that's all that's happened. And then at this point, you need to just plug it into a calculator. You might have to do dividing on a calculator, or you could literally put it in as a fraction. This should give you 48.541 dot dot dot, which is approximately 48.5. And again, this is just your side length that we're finding without Pythagorean theorem, okay? Last one. So 27 degrees points to this side. This must be the opposite side. 90 degrees points to the hypotenuse. Well, that leaves us with just adjacent, which is always the one just next to the angle, right? So, which ones are we given? Opposite, adjacent. Hypotenuse is not given. Goodbye. So, in this case, SOHCAHTOA, right? Think about it that way. TOA, well, that's just tangent of 26 degrees is equal to opposite over adjacent. Well, that's just tangent of 26 is equal to opposite over adjacent. Here we have to do the switcheroo thing again, so I'm just going to do it. X is equal to 10 over tangent 26. Again, we did the same exact thing as the previous problem. We just switched places, right? So these two switch places, now they're in this order. And so plug that into your calculator. You should end up getting 20.503 ... And let's round that off, or rather not round it. 20.5 is going to be your side length that we found. Okay. So almost done. The final frontier, okay? This is the one where we deal with the inverse functions, okay? The inverse functions, you might recall, are a ways to find the angle, okay? You might remember that we're trying to find the angle. So up till now, we've been finding side lengths. Well, what if we wanted to find the guy actually inside the triangle? How long, how big is that angle? Okay, that's what we're accomplishing. Same exact thing. Again, write down SOHCAHTOA if you need to. Okay, you really shouldn't have to look at your notes to find out what sine, cosine, tangent is or how to use it. I'm going to replace every question mark with the theta symbol because, again, I just like working with neater variables. Question mark's not exactly a variable. This guy points to the opposite side. This guy points to the hypotenuse. This guy's the adjacent side. Again, we don't need this guy, right? Hypotenuse is not really necessary. So we're just given opposite and then adjacent. Well, you should know this by now, right? Opposite and adjacent, that's going to be this guy, right? Tangent. So I'm going to go with tangent of theta. Oh, sorry. In this case, we're doing the inverse operation. So tangent inverse to find the angle. And then according to SOHCAHTOA, right, these guys right here, that's going to be opposite over adjacent. Well, that's just tangent inverse. Which one is opposite? That one's going to be this guy. So 56. And then adjacent, that's this guy. Tangent inverse of 56 over 26 is approximately, you don't even need to simplify that fraction. If you plug it into your calculator, you should end up with this guy. And again, you can round this one to just 60. Oh, you know what? This one is to the nearest degree. So I caught myself there. Degrees are usually written best in terms of whole numbers, meaning no decimal at all. So in fact, I'm going to erase this. This right here is just going to be 65 degrees. Okay, if they said round it to the 10th, then you would absolutely do 65.1. That is not what they're telling us. Let's do this again. Let's call this theta. We know that this is the opposite side. We know that this is the hypotenuse, which makes this the adjacent side. Well, again, these two, totally unnecessary. Goodbye. Which two, and again, if the triangle's inverted, like think about it like, rotate your paper over so you can maybe see it better. That always tends to help me. But in this case, you're given the adjacent side and your hypotenuse side. Think back to SOHCAHTOA, right? Which one has adjacent and hypotenuse? Well, AH is only this one, Ka. So that's going to be cosine. So let's find our angle theta using cosine inverse of A over H again, right? Which is adjacent over hypotenuse. That's going to give us cosine inverse of 27 over 36. On your calculator, that's going to be approximately 41.409 dot dot dot. Well, that's just going to be 41 degrees. There's no rounding. This is just to a whole number. There you go. And again, these are what you're finding, 41 degrees. Last one, okay? This one is going to be theta. This one is opposite. This one is hypotenuse. We know the last one is adjacent, but we don't need that guy. So these two. Well, which one uses O and H? Right? Think about it. In fact, let me just write the first two letters. You should know this by now. SOHCAHTOA. S-O-H. Right? So sine, opposite, hypotenuse. Oops, sorry, I'm like getting ahead of myself. I'm going to rearrange some of this because we're finding the inverse of it, right? Because we're trying to find the angle. Because we're trying to find the angle, we got to restructure this a little bit. So inverse theta. Sorry if you're writing along with me. Sine inverse of opposite over hypotenuse is going to be 54 over 59. Again, be very careful not to switch these numbers. It's always op over hype, okay? Let's get some hype in the chat. We're almost done. This guy is going to be, if you plug it into your calculator, 66.241 dot dot dot. That is approximately 66 degrees. Oh, let's get some hype in the chat. Make sure to go kiss your ops, and then don't get a tan. Those are my little trig puns for the day. And yeah, that's it.